In this given problem, dimension of U and dimension of W is 4, dimension of vector space V is 6. So we have to find dimension of intersection U intersection W. We are seeking dimension of this space. Intersection is a subspace. Also, sum of subspaces U plus W is again a subspace of V. So dimension of U plus W cannot exceed dimension of vector space V because of it is subspace. Subspace means subset. Subset cannot have dimension higher than vector space. So dimension of sum cannot exceed dimension of vector space V. It means the dimension of U plus W is at most 6. Dimension of sum is at most 6. Now we have this type of information up to here. Also we know that dimension of intersection U intersection W is equals to dimension of U plus dimension of W minus dimension of sum U plus W. So dimension of U is 4, dimension of W is 4 minus dimension of sum U plus W. It means 8 minus dimension of U plus W. And dimension of U plus W from equation 1 is at most 6. So what are the possibility? 1, 2, 3, 4, 5, 6. So if I use higher value 6, then possibility of dimension of intersection dimension of intersection U intersection W is 2, 3, 4, 5. When I use min value, then up to 7, 6, 7. So these are the possibility. Also it is given that U and W are distinct. U and W are distinct. So intersection always a subspace. It contain at least one vector. It is 0. It may be 0 and other vector are possible. So intersection dimension, because distinct, cannot be 4, because we know that dimension of intersection U intersection W at most min value of dimension of U comma dimension of W, because intersection always a subspace of U and W. That's why min value. And min value is 4. So it cannot exceed dimension of intersection cannot exceed 4, but because of distinct it cannot be 4. So possible dimension are 2, 3. Possible dimension are 2, 3 because dimension cannot exceed 4. So these possibility are cancelled. So we have remaining 2 and 3. Option C are true.